How about now?
Yes, yes.
Yeah,
Thank
now
you.
it's recording.
Okay. So this is called simple interest. This is the formula of simple interest. If we write it formally, we denote that I equals to PRT. P is called principal amount, the amount which we invest, and R is called interest rate. R is called interest rate, and T is called time. Understand? In simple interest, normally we deal time within years. For example, if you are given time, let's say 9 months. If time is 9 months, we will convert it into years. We will divide it by 12. If you are given time, let's say 3 months, 3 months, we will convert it into years by dividing it by 12. So we always express time in years. So in simple interest, maybe you will be given time in months, then you will convert it into years. So here you can see that find the interest on a boat loan of a dollar 5,000. You need to pay interest on dollar 5,000. Whatever you will see the big amount, that would be most of the time your principal amount. R is your interest rate. R is 16%, and time is 8 months. So we convert 8 into years, it will become 8 by 12. So you can substitute the values into the formula. When you substitute them, you will get the result. I equals to 5,000 times 0.16 times uh, number of months in terms of year, like 0.666. 8 by 12 is 0.666, so that is your interest. So the amount which you will return, we denote it by A, P plus I. So P was 5,000, I was 500, so that is 5,533. So actually, one more thing I would like to mention here. I have already uploaded this lecture in a recorded form on BB and also on my YouTube channel. I'm just revising it, reproducing the same thing. So the point is, when I already uploaded it, you need to go through from it, and now we should discuss the problems, like problems related to your assignment. You can tell me, I try to solve this question, how to solve this one or that one. Do you understand?
Hmm.
Or
Well,
Yeah.
this one we already studied in our previous class, I think. Not in the previous class, but in
in college
uh
I know.
last semester.
But in college algebra, we just discussed, I think, simple interest and maybe compound interest. We did not discuss after that.
Hmm.
Yeah. So this is just kind of your revision. I think it would be better. You can get even more perfection in that. So here now, uh, we can say that, let's see, here we can go to another example. The total amount to be paid back for the boat loan would be dollar 5,000 plus the interest is this, and here we are denoting this. This is the interest formula, P times R times T, and the amount which you need to pay back, we denote it A equals to P plus I, where I is P times RT. From here we can take out P, which is P plus RT. So this is the formula which you need to pay back in total. Okay. So here we have already discussed this formula, and we solve one more example. Find the total amount due on a loan of $6,000. This is your principal amount, 6,000 at the rate of 16%. R is 16%. Time is 15 months. So T equals to 15 by 12 in years. You can simply substitute that how much amount due. there are two ways. First, you can calculate the interest, like 6,000 times 16% times 15 by 12, you can get interest, and then the amount due, you can find P plus I, like 600, sorry, not 1000, 600 plus interest. Is that clear?
Yes.
Yes.
Okay. So this is the formula which we have already discussed. So A is 720. Now here you can see that what is annual interest rate earned by 33 day. Now 33 day means 33 over 360. You can divide it by 365. That is your choice. Either you divide it by 360 or 365 with maturity value of $1,000. So you are told now that A is 1,000, that sells for $996. Your P was 996.16. So from here you can get your interest rate. You can see if did you go through from this PPT? If you have any question about this calculation, I mentioned it earlier. I will explain it in live tutorial. If you have any question about this calculation, please let me know, any of you, that how did I get R.
Okay, thank you.
Okay. So a departmental store charges 18.6% interest for overdue account. How much interest will be owed on a $1,080 account that is 3 months overdue? So time is 3 months. So you can convert it into years, like by dividing it with the what happened. Hmm. By dividing it by 12, R is 18%, here R is 18%. So P is 1080. So you can simply substitute the values and you can get interest. So simple interest is quite easy to calculate. Now we jump into the compound interest. How many of you went through all these PPTs? Huh?
You mean watch the videos?
Yeah.
Yeah, I've watched all
Yeah,
of
I
them,
watched the videos.
except for
Well,
lecture 8.
No, I mean, I'm talking about this lecture, this particular lecture.
Yeah, chapter 3. I watched the video in lecture 3.
All of you except few.
no, I watched the videos as well.
So I think it is the same thing. You are supposed to solve the problems and then we can discuss your problems. If I keep spending the time again and again on the same thing, I don't know if it is worth for you. If you want me to revise it once again, I can go over it. No problem for me. But just tell me straightforward.
I actually do have a question.
Okay.
From the last presentation you asked us if we had any questions about R. I don't understand how you got the 996. Is that the number, or 96?
Which section? 3.2. Like here you can see that this is 3.2, 3.1 or 3.3.
I think 3.1.
Okay, let me open it then. This is 3.1. Which one?
one of your questions asks about like, you said in like a year there's 365, and you had the number 100, and you were doing 100 take away a bunch of numbers. I'm sort of.
That from this one?
I think so. I'm not sure now. I'm getting confused. I don't
Yeah.
know. This one, yes, yes, exactly, yeah.
Yeah.
Why do you make it equal? Is it because the question
This
is 1,000 equals 996.16?
formula, because of the formula.
Okay, so just because of the formula. Okay.
Because A is the maturity value, the amount which you deposit. The original amount which you had deposited was 996. Its maturity value was 1000, right?
Mm-hmm.
A is 1000, P was 996.16. Interest rate was, I think, what annual interest rate? We need to find interest rate, and T was 33. We converted into number of years, so we divided by 360. So T equals to 33 by 360. We can we are just simply substituting values there. Here R is there, and we can find here R. Is that clear?
Okay, yeah, that's clear now. Thank you. I understand. Get that.
Okay. Okay. So we can open the other slide now. If anybody else have any question, please, I always appreciate your question. Then it gives me the feeling that yes, you are participating, and it gives me motivation as well. Okay. So first of all, the most, in mathematics of finance, the most important thing is how can you differentiate among the problems, that either you are given simple interest problem, or you given compound interest problem, or you given annuities, or what. So compound interest, the very basic thing in simple interest and compound interest is, in compound interest you will be given compounding periods. You will be given compounding periods. Like, compounding period means that how many times are you calculating interest in 1 year. For example, if we say that compounding period or compounded annually, we denote it by M. So we say that in 1 year we are computing interest 1 times. If we say that compounded semi-annually, that means M equals to 2. If we say that compounded quarterly, then what would be M?
4?
Very good, 4. If we say compounded monthly, then M would be, Subhan?
Yes, sir.
Then M, what would be M? For
8.
monthly. Misha?
8.
Misha?
Would it be 1/12?
Yes, not 1 over
Oh, no,
12.
just 12. Yeah, just 12.
There are 12 months in 1 year. So that is what we mean by compounded monthly or something like that. So I was explaining the difference between simple and compound. In compound, you would be given compounding periods. So from compounding periods, we will analyze that this is a problem of compound interest. Rest of the things are very simple. You just need to calculate the interest. And another difference is between simple and compound is, in in simple interest, uh, you don't reinvest your interest, but in compound interest you reinvest your interest and you don't withdraw it, and over the period you get more interest in case of compound interest as compared to simple interest. So here we solve one example. You can see that suppose a principal of $1 was invested in an account paying $6% annual interest. Here you can see that I have highlighted compounded monthly. Compounded monthly. So that if M is, if M equals to, in that case, compounded monthly, M is 12. Now, principal amount P is 1, R is 6%. How much would be in the account after 1 year? What is time? Time is 1 year. So what I want you to extract this data, and what you need to calculate is very important. How much would be in the account after 1 year? You need to find the future value. We denote future value by S, that what would be in the account. And in compound or in all mathematics of finance, another very important thing is how to find the interest rate, I. What is I? I is interest rate per year divided by compounding periods. Do you understand? So I would be, in that case, interest rate is 6%, compounding periods, we are compounding monthly, so I is 6% over 12. So the actual formula will become, you can see that we can substitute the values here, and we can get, he solved it to calculate the formula, but we can calculate it directly. Let's say S equals to P times 1 plus I raised to power N, where N is M cross T, I is R by M. So we can substitute the values. It will be P is 1 plus I is R by M, which is 6% by 12 raised to power M. M is 12 and number of years T is 1. So when you will solve it, you will get compound interest. So here you can see the formula for compound interest. N is M cross T, I is R by N. In general, we write here in the book, he is denoting compound interest by A, but normally I denote it by S. So this is your choice. You can denote it in either way. So S equals to P times 1 plus I raised to power N. So can you hear me clearly?
Yes.
Yes.
Yeah.
Okay. So here S equals to P times 1 plus I raised to power N. You can substitute the values and you can get the answer. Here things are given. I is the rate per compounding period. R is the annual nominal rate. So here, if you read this example, find the amount to which $1,500 will grow if compounded quarterly. As I said, in these types of problems, it is very important to list down the information, what you need and what you need to calculate. Find the amount to which $1,500 will grow. We need to find S. We are given P, that P will grow compounded quarterly. M is 4, R is 6.75% and T is 10. We can simply substitute the values into the formula and we can get the answer. Any questions so far?
No.
Okay. So here you can see that I need your attention. I have already explained this thing in the uh, recorded lectures. In this example, compounding period was 4. What was compounding period? M was 4. You can see
4.
M is 4. Understand? Now if I increase M instead of 4, I say it is monthly. I increase M, here it will become 12. Say yes or no. No? Hello?
I'm
Hello?
not sure. Doesn't it say 10 years?
No, no. I'm discussing
Yeah,
something.
10 years.
For example, just forget it. Find the amount to which $1,500 will go. P is 1,500 compounded quarterly. M is 4. R is 6.75%. T is 10. When you substitute the values into the formula, you will get S equals to 29.5, like here. Understand, Kathleen?
Yes. Yeah.
Now we are saying that if we increase our compounding periods, like we say that instead of compounding quarterly, we say that it is monthly. Here we say it is monthly. What would be the change? The change would be M will become 12. Understand? Here,
Yeah.
here it will become 12. Then this amount will increase. It will become 29, maybe 45.50. If we say monthly, if we say not monthly, we increase it further. We say that it is, let's say, daily. Then what would be M? In how many days per year? Then
365.
yeah, here it will become 360. Are you following?
Yes.
Yeah.
Happening. You see, in that case, S would be 29.46. It is increasing, but it is increasing slightly. When M was 4, it was 29.29. When M was 12, it was 29.45. When 360, it is 29.46. It is increasing, but slightly, like this. Understand? So if we increase and we say that we don't compute interest weekly, we don't compute interest daily, we don't compute interest after every hour, we don't compute interest after every second, but we want to compute it continuously. If we say that daily, it would be M would be, after every hour it would be 24. Furthermore, after every second it would be 60 times 60. So M will increase and increase, and if we keep increasing M, we will say that compute interest continuous. Compute interest continuous. uh, in that case, the formula will be S equals to P times E raised to power RT. Before doing this, we solve one more example. Like here, you can see that to what amount will $1,500, we have already solved this. Here you can see that Suppose a house that was worth $68,000 in 1987 is worth like this in 2004. Assuming a constant rate of inflation from this to this, what is the inflation rate? We need to find R. We need to find R. Principal amount is 68,000. It went to 104 in 2004. So T is 17 years. We can simply M is annually. So M is 1. When you substitute the values, you can get the interest rate. R is 0.0253. Any questions so far?
No.
Yeah. How do you know which formula to use? Like A equals P times 1 plus RT, or A equals P plus times 1 plus R over N. Oh, this is wrong.
Yeah. So far, we have just discussed two formulas. One is simple interest, that's P RT, and one compound interest, P times 1 plus this. This is for compound interest. If I say that we know S, we know P, we know I, it means that we need to know what is N. So we will substitute the formula and we solve it for N. Similarly, it depends what you are given and what you need to calculate. Clearly, he says what is time, how long, or what is interest rate, or what would be the amount in future, or how much you need to deposit. So it depends upon the questioning what you need to calculate and what are you given. That is what I am saying, that in these problems the only thing is the right decision, that which formula you need to use and what you need to calculate. This is the only thing. And I will solve some examples from the book, and we will just discuss the problem, that what we are given and what we need to calculate and why do we need to calculate these things.
I have a question.
So for this one, we use the first one. Do we use a simple? Do we use a simple interest formula for this one, computing the inflation rate?
What do you mean by first one?
So for this example that you have on screen right now, we use the we use A equals P times 1 plus RT. Yeah.
Mm-hmm.
Okay, that was my question.
For this particular problem, if I go back, if you see only this thing, now how will you know that which formula you need to use?
It's too late. It doesn't, because it doesn't have the compounding periods.
Yes, but still, how do we know that we need to use compound interest?
Cost of inflation.
I gave you two options, two hints. One is compounding periods. Almost more than 90% will have this sentence that compounding period is this, compounded monthly, compounded daily, whatever. It will tell us that we are using compound interest formula. The second thing is we reinvest our interest. All right. We reinvest our interest and we don't withdraw our interest. This is the difference, basic difference between simple interest and compound interest. Suppose a house that was worth 68,000 in 1987 is worth 104,000 in 2004. Now in the increasing the worth of house, this is the worth of house. You are not getting any interest on that, which you can withdraw and which you can use. Which means that, in other words, we can say that we are reinvesting our interest. We can say that we are reinvesting our interest because after every month or after every year, we don't have to withdraw it. So that is the reason why it is a compound period. It is a compound interest. Is that clear?
Yeah, that's a bit clearer.
Okay.
I just need to do more problems, I think, to draw interest.
I have a question about you wrote if we don't know what n is, what's the equation? Because n is an exponent, right?
Yes.
So what would the equation look like if you're trying to find n?
Isn't it m times t?
Yeah. It is not actually n, it's m cross t. Here we have this example. Look at here. How long will it take dollar? First of all, as I said, it is very important in these problems that you should analyze what you are given and what you need to calculate. Like here, how long will it take? It means we need to find t. For $5,000, to grow to 15,000, if the money is invested at the rate of 8%, R is 8.5% compounded quarterly, M is 4. M is 4. Understand?
Yeah.
Yes.
Now we substitute the things into the formula. 15,000 equals to 5,000 times 1 plus this raised to power 4t. We need to find t, and there are two very famous properties of logarithm. You can see here, I have mentioned it here. If you have log of a times b, we can write it log of a plus log of b, and vice versa. Similarly, if you have log, this ln means natural log. Ln times a raised to power b, whatever is in the exponent, whatever is in the power, it comes down. It comes down. So it is b times log of a. We use this property of logarithm, and natural log of e, you can check it in your calculators even, it is 1. Kathleen, this is the answer of your question. So we need to find t, and it is in the power. We need to bring it down. We can bring it down only if we take natural log on both sides. So we apply natural log on both sides. The equation is 15,000 equals to 5,001 plus 0.085 over 4 raised to power 4t. We have this 0 will go 5 with 3, so we have 3 equals to 1 plus, it is if we divide it, okay, I write it, let's say 0.0855440. Now we take natural log on both sides. We take natural log on both sides like this, and it will become like this. So it will be log of 3. Because of logarithmic property, 4t will come down. So we will get log of 1 plus 0.021. Is that clear, Caitlin? So log,
Yeah, I get that.
we can divide it by log of 1.02 times 4, so we can get t. So the only thing is we just apply natural log on both sides in order to bring down t. Is that clear?
Yeah.
Yes.
Any question? If you have
Yes.
any question, it is always welcome, you know. So don't hesitate. Just give me many questions, okay?
Okay.
Continuous compound interest. We have already discussed the formula for continuous compound interest. Now I need everybody's attention. I just revise it once again. We apply simple interest when we are not given compounding periods and we are not reinvesting our interest. One of the condition would be there. through which we can analyze that either we are using simple interest or what. Okay, in compound interest, you will be given compounding periods. If you are given compounding periods, then you will apply compound interest. The third one is compound interest continuous. It is very simple. You will use compound interest continuous formula when you will see a word continuous in the statement. If you don't see the word continuous in the statement, you will never use compound interest continuous formula. Sometimes, or even most of the times, when students are confused which formula they need to use, they just go for compound interest continuous and they get 0. You will use compound interest continuous formula when you will see a word continuous in the statement. For example, uh, here, what amount will an account have after 10 years if $1,500 is invested at an annual rate of this, compounded continuously? You can see here clearly the word continuously is written in the statement, so it means we need to use compound interest continuous formula. P is again the principal amount, which is 1,500. R is the interest rate, 6.75%, and T number of years. For 10 years, you can substitute the formula and get the result. In your calculator, you will be given function E. Otherwise, E is equals to 2.71 something. And if you don't need to use 2.71, you can see the function in your calculators, take its power, and you can get the result. Understand?
Yes.
Yeah.
Okay. So APY. APY tells us that I tell you that when do we apply annual percentage yield? You know, sometimes there's a very good example in the book. I will solve it. I will try to solve that example for APY. You know, sometimes it happens that you go to a bank and one bank says that we offer you 5% interest over a period of 6 months or 6 years, and you will deposit that much amount. Another bank says that, okay, we will give you 4.5% and you deposit your that much amount for 1 year. Now, apparently, one bank is paying you 5%, another bank is paying you 4.5%, but maybe in the long run, the one you paying apparently less, which is 4.5%, maybe that is beneficial for us. So annual percentage yield tells us that which bank is actually paying how much, which is called the effective rate. This is so called the effective rate. So that is why we use annual percentage yield. And it is very simple. It would be given in the statement that we, and now how do we, how would we know that when we need to apply annual percentage yield? So it would be a straightforward question, calculate annual percentage yield. You don't need to worry about compounding periods or thing like that. And I have already explained that why do we calculate annual percentage yield in order to know that which bank is actually paying us more rather than just giving us an attractive packages or thing like that. Similarly here, we saw one example. What is the annual percentage yield for a money that is invested at the rate of 6% compounded monthly? So you have the formula for annual percentage yield. You can substitute them and you can get the answer. Apparently this bank says 6%, but the effective rate is actually 6.16. I will solve one example from the book. I really like that example actually, which really tells us the central idea of annual percentage yield. So now I jump into the third section of this topic, which is called annuities, annuities. Are you listening?
Mm-hmm.
Yes.
Yes.
Okay.
Sorry.
Can you listen me clearly?
Yeah.
Yes.
Okay.
Yeah.
That is good. Okay. In section 3, first of all, I will define the difference. Uh, you know, you deposit, now listen all the situations, okay? Keep all the situations in your mind and then see the difference among them. You go to the bank and you deposit $100 into the bank, and bank offers you 10% interest per year. After 1 year, you go to the bank, you withdraw the interest, your $100 is still there. After second year, you go to the bank, you draw another $10, that is your interest, but still your $100 is there. So it means that we are in the situation of simple interest. This is simple interest. Okay. Now we jump into the compound interest. You deposit $100 into the bank, and bank says that we will pay you 10% interest per year. You say that I don't want to withdraw my interest, I want to reinvest my interest. Okay, fine. After 1 year, now your account has $110 because your 10% interest is added into your principal amount. After second year, you will get interest on your 110, not on your original principal amount, which is 100. So after second year, your amount would be 121 in your bank. So likewise, your amount will increase and you would be given compounding periods as usual. So this is the compound interest. Okay. Now we come to the annuities. You go to the bank and you don't deposit only $100. You tell your bank that every month or every year, my salary will come into my account. Understand? So you will get salary after every month or after every week or after every quarter or after every year. So there would be a sequence of equal periodic payments. That would not be like simple and compound interest. It would not be only one principal amount, but it would be a sequence of equal periodic payments. And you would come to know this through a statement. I will explain each and every word of every problem, through which we will come to know that yes, we are making a sequence of equal periodic payments, or there is a single payment. And this is the only difference between compound interest and future value of annuities. Because in annuities and in compound interest, you would be given compounding periods in both cases. So the only difference through which we can come to know is the sequence of equal periodic payments. Is that clear?
Yeah.
Okay. So this is the formula for future value of annuity. PMT is the sequence of equal periodic payments. I, we know, which is R by M, and N, we know, which is M cross T, and FV is the future value of annuity. Here, we solve one example. As I said, in these problems, it is very important to extract the data. It is very important to extract the data, and rest of the things are very simple. Suppose dollar 1,000 payment is made at the end of each quarter. Through this statement, each quarter, I know that this is sequence of equal periodic payments. This is PMT. Understand? We are making $1,000 at the end of each quarter after every 3 months. Is that clear?
Yes.
Yes.
Mm-hmm.
And the money in the account is compounded quarterly. Compounded quarterly means we are given M equals to 4. At the rate of 6.5%, we are given R 6.5%. For 15 years, we are given P equals to 15. How much is in the account? We need to find future value. After 15 years, how much would be in the account? We need to find FP. Is that clear?
Yes.
So you know the formula. We can simply substitute. This is the formula: future value PMT times 1 plus I raised to power n minus 1 over I. You can substitute the values and you can get what is FV. Okay. Now, if I change the statement, I need everybody's attention. If I change the statement, suppose a $1,000 payment is made into the account, is made in the account and is compounded quarterly, is it still a problem of annuity?
Can you please say it again?
You can just remove that portion which I just crossed
Oh, okay.
black pen with black pen.
Oh, okay, okay.
Now tell me, is it still a problem of annuity?
Yes?
Okay, who are you, Kathleen?
Yeah.
Okay, how is it problem of annuity?
I think so because you have your time, you still have time of 15 years, and you have your interest rate of 6.5, and you still have your M of compounded quarterly, and you still have your PMT of
No,
1,000.
no. I just made a long speech just now. Tell me,
Oh.
how do we identify, is it a problem of annuity or compound interest? First tell me this difference.
Because it's the future.
No, Kathleen, you tell me.
Okay, sorry.
Yeah, because it's asking you how much is after 15 years,
No.
period.
I'm asking, how do we identify that this is a problem of annuity or compound interest? Forget this problem so for for the time being. Simple, tell me, how do we identify this is a sequence of equal period, this is a problem of annuity or with compound interest?
Compounded.
I'm not sure.
Who
Is it
else?
compounded?
Wait, so that does that mean for it to be annuity, it has to say at the end of each quarter and the money is the...
Yes, this is the
Okay. So this is just compound interest, and then at the end of each quarter, then that becomes annuity. Okay, I get it now.
exactly, that is what I mean, and that is what actually I want everybody to understand. That if I remove this
Well,
sentence, which I just crossed,
sorry.
yes, please.
Will an annuity question always say at the end of each quarter?
No, that is what I am telling you. This is I mean, this is a different phrase. Maybe they can change their language. For example, I say, suppose your first payment is $1,000. Understand? Suppose your first payment is $1,000 and you keep depositing up till 15 years quarterly. Now this first deposit, this word first deposit, I should write it. If I change the statement, suppose your first deposit is $1,000 and it continue till 15 years, compounded quarterly. Is that clear?
Yes.
Yeah.
This first deposit, now this word first deposit tells us that there are second deposit, there is second deposit as well, there is third deposit as well, and it will continue till 15 years. So it is still a problem of annuity because this first deposit, the word first deposit tells us this is a sequence of equal periodic payments. If I remove this word first deposit, then it would be a compound interest. Similarly, in this problem, At the end of each quarter, if we remove this word, it means this is not now any more sequence of equal periodic payments. It would be now compound interest. But if we add this sentence at the end of each quarter, then it would be a problem of future value of annuity. Is that clear?
Yeah.
Is it clear to everybody?
Kind of complicated, but I kind of get it. Yeah.
Okay, because you are out of the room.
No, I keep switching back and forth between my phone and my computer. I'm here now. My internet's bad.
Okay.
Sir, where are the PPTs? I didn't find them on Blackboard.
Come on. I upload the link under the information section, and I upload the link even in the group, in WeChat group.
I've seen the lectures. I didn't see the PPT.
I can still see, you can see now, can you see the group? Here I have shared all the links.
Just a
Link of lecture 8.1. This is,
Oh no, I just meant the PPTs, not the lectures. You don't upload the PPTs like without the lectures.
okay, I will upload the PPTs as well. But the
Okay,
lecture
thank you.
itself contains PPT inside the lecture.
No, the lectures. Yeah, I know. I watched the lectures. Yeah.
Okay. So my next question is, if we solve this problem, our future value is 100,000. Our future value is 100,000. Now, what would be the interest? Who can tell me what would be the interest?
Uh, 336.68.
How do we calculate it?
I don't know. Oh, you take, okay, I don't know how to explain it, but you take for the 15 years times, no, wait, I don't know.
No, you are in the right direction. Tell me.
So you see how much you put in and
Mhm.
how much you have in the end, and then just calculate the,
Very good.
yeah.
Very good. First of all, we need to see how much did we deposit. We are depositing $1,000. We are depositing $1,000 after every quarter. After every quarter. What is M? M is 4. Understand?
Yes.
Yes.
After every quarter means 4 times per year. And how many years? Till 15 years. We deposit $1,000 after every quarter, and we did this deposit for 15 years. So it means that we deposited 60,000 in 15 years. That is 100% our amount which we deposited. After 15 years, what we get? We get 100,000 and 336. Now, if I write it in terms of formula, what is 1000? That is our PMT. What is 4? 4 is our M. And what is T? 15? 15 is number of years. And how do we calculate the amount which we get after 15 years, which is FV? FV minus PMT times M times T. Is that clear?
Yeah.
Yes.
How do we calculate interest? Okay. So this is the formula. How much interest was earned over 15-year period? So I equals to FV minus PMT times M cross T.
So wait, is this formula the same for all problems that are like FV equals PMT times 1 plus I, blah blah blah?
Only for future value and only
For future value,
Yeah,
value.
only for the
Okay.
case of calculating interest.
Okay. Could you go back? Oh no, there it is. Okay.
Is it fine?
Yeah, it's fine. It's fine. Just trying to follow.
Hmm. How much must Harry save each month? This first sentence. This first sentence tells us that this is a problem of annuity. How much must Harry save each month? Each month, how much you need to save? So it is a problem of annuity. To buy a new car for $12,000 means after some times you want to accumulate to a $12,000. So your future value is $12,000. To get this amount, how much you should save each quarter, each month in 3 years. In 3 years, at the rate of 6% interest, compounded monthly. Compounded monthly. So you need to calculate PMT. You know the formula FV equals to PMT 1 minus I raised to power n minus 1 over I. You can substitute the values. 12,000. We need to find PMT 1 minus I 6% over 12 raised to power m cross t 4 by 3 divided by 6% over 12. From here you can solve it for PMT. Is that clear?
Yes.
Yes.
So here, you can simply substitute the values into the formula and your PMT will be 305. You need to save 305 each month in order to accumulate $12,000 for 3 years, in 3 years. Okay. Okay, now we discuss present value of annuity. Now we discuss present value of annuity. Listen my words very carefully now. To differentiate between future value of annuity and present value of annuity is very sensitive. It is very critical. Students always make this mistake. They cannot differentiate between future and present. Understand?
Yes.
Okay.
Mm-hmm.
When you will read the statement, and if this statement gives you the perception that after prescribed period, you will get a lump sum amount, then it means that you are dealing with future value of annuity. Understand? And if after reading the statement, and if it gives you the feeling that you left with zero balance into your account, then it means it is a present value of annuity. I give you two examples. For example, you are depositing your salary into the bank for 10 years. This is a sequence of equal periodic payments. After every month, you are depositing your salary into the bank. After 10 years, you will get a lump sum amount. Understand?
What is a lump sum amount?
In total,
Okay.
at one time, after 10 years, you will get a big amount. Understand?
Yes.
Yes.
Now, I change the statement. You borrow $10,000 today from the bank. Understand? And
Yeah.
you decide you will pay $100 every month to repay this loan, to pay back this loan. And you will pay back this loan in 10 years. Now you are paying every month $100. Now after 10 years, would you have some amount into your bank, or you will left with zero balance? I make it simple. I borrow $100 from you. Understand? Today,
Mhm.
Yes, yes.
I pay you $10 every month. After 10 months, how much amount would I have?
Zero?
Zero? Zero.
Of course, zero, because I am paying back. I am paying back. I am paying back. And although there is sequence of equal periodic payments, but still I left with zero balance. So similarly, in future value of annuity, for example, again I open future value of annuity just to compare. Now, if you read this example, it tells us clearly that after 15 years, if you read this example, you will know clearly after 15 years, you will have a huge amount in your account. Suppose $1,000 payment is made at the end of each quarter and the money in the account is compounded quarterly at 6.5% interest for 15 years. Now, after 15 years, you will have a lump sum amount into your account. Is that clear?
Yes.
Now,
Well, what's the difference between this and the other, the present value?
I am coming to that.
Okay.
Now I directly read some example. This is by the way, this is the formula for present value of annuity. Everything is same. I, you know, PMT, you know, PV is present value. Now, if you read this example, it will gives you clear impression that after 2 years, you will left with zero balance into your account. After prescribed period, you will left with zero balance. How much money must you deposit now at 6% interest compounded quarterly in order to be able to withdraw $3,000 at the end of each quarter year for 2 years? Who can explain this? That why it is a problem of present value of annuity and what is given and what he wants us to do and what is the situation in this problem?
So so future value is when you're trying to find out how much money you're gonna have in the future if
Yes.
you deposit some amount now, right?
If you deposit a sequence of equal periodic payments.
Yes, yes, yes. And then present value, it asks how much you should deposit now to have. Wait, no. Same thing.
There could be different types of situations, but one thing would be common among all the situations, that you will left with zero balance. In this particular problem, in this particular situation, uh, for example, you are going to retire now, right?
Yeah.
Hmm.
You are going to retire and you don't feel that you can work anymore. You don't feel that you can work anymore. So you decide that every month, I need $3,000 for my livings. And you decide that maybe I will live for another 20 years. So I must have enough money into my account now, today, so that I can withdraw 3,000 every month for my livings. Now, after 20 years, you will withdraw 3,000, 3,000, 3,000 every month or every year for next 20 years. After 20 years, this is a sequence of equal periodic payments. Either you deposit or you withdraw, but it is a sequence of equal periodic payments. You are withdrawing $3,000 every month or every year. After 20 years, you will be left with zero balance. So this is a present value of annuity. Or in other words, you will have a lump sum amount today. You will deposit a huge amount today in order to withdraw 3,000 every month. So in present, today present means right now you have a lump sum amount. You don't need to wait for 20 years to have lump sum amount, because in that case it would be a future value. Is that clear to everybody?
Yes.
So in present value, you have a lump sum amount at the beginning of the problem. In the future value, you have lump sum amount at the end of the problem. Yeah?
Not end of the problem, end of the time.
End of the time, yeah, end of the
End
time.
of the prescribed period. Is that clear?
Yes.
So
Yeah.
how much money must you deposit now at the rate of 6% compounded quarterly? As I said, things are very simple. You know, you can extract the data from these three lines. You can substitute them into the formula. Here they are denoting PMT by R, but you can still denote it by PMT, no problem. So your present value would be 22,456. Now, in that case, how will you calculate interest? Who can tell me now?
Is it the same R over M?
No, interest rate. You know, I mean, interest. How much interest will you
Oh,
pay?
uh,
How will you calculate interest? Kathleen,
To calculate the interest?
P times R times T.
sorry,
Yeah.
come again.
I equals P times R times T.
P times, let me write what you are saying. P times
R
R,
times T.
then
It's the interest.
that is Carolota?
It's Carolina.
Carolina. No, that is not correct.
Is interest the interest rate divided by the
No,
how much it's compounded by?
no. You see, how much the thing is, how much you deposit or how much you get. What is your sequence of it? Here, how much amount are you getting?
Is it R divided by M?
No.
Oh, okay. I'm joking. No, I'm joking.
Interest is PMT times M cross T minus what you have today. This is what you pay and this is what you have now.
Okay.
So the present value of all payment is 22,000. The total amount of money withdrawn over 2 years is 24,000. Thus the accrued interest is difference between the two amount. Is that clear now?
Oh, not interest rate, like the interest, like the difference between
Yes.
what you have now and what you gave. Oh, okay, I get that. Sorry, I thought you meant interest rate.
No. Interest.
Interest. Okay.
Okay. So similarly, a bank loans a customer $50,000 at 4.5% interest per year to purchase a house. The customer agrees to make monthly payments of each month. Who can explain each part of this problem and tell me, is it annuity, is it future or present? Now it is a bit different than what we have discussed before, but it is totally based on what we have discussed. Who can answer me for this?
it's present, right? Because we have a lump sum amount in the beginning. And then like multiple next 16 years.
Anyone else?
Mm,
Is
Anyone?
it annuity because it's monthly payment?
It is annuity, but yes, this is the first step. Is it annuity or compound interest? Yes, it is annuity. Now the second question is it present or future?
it's
Present.
present because you have a lump sum at the beginning.
Yes, it is present value of annuity. This is one of the hint. It can be wrong in some examples, but this hint can never be wrong. After 15 years, would you have a lump sum amount or you will left with zero balance? A bank loans a customer 50,000, you have 50,000 now, but when you will make all sequence of payments, at the end you will pay back 50,000, you will left with zero. How much of
Hmm.
the payment if the debit is to be retired in 15 years? You need to retire this debit in 15 years in 180 payments. After making 180 payments, you will left with zero balance. Is
So it's
that
present.
yeah, it is present.
Okay. Yeah, that's clear.
So you can just uh, go through from it and now in 5 or 10 minutes I want to go through quickly some of the examples from the book. For example, if $1,000 is invested in an account that earns 9.75% compounded annually for 6 years, find the interest earned during each year. Find the amount in the account at the end of each year. Organize your result in table. How will you solve this? What type of problem is this? Hmm?
Mm.
Which question? I couldn't hear you
I'm
before.
thinking.
Sorry.
41.
Is it just compound interest?
Is it?
Mm. Is it annuity because it's saying find the interest earned during each year at the end of each year?
Okay, one student is saying compound, one is saying annuity. Who should we believe?
Mm.
Do we have like a third student to get the vote? How do you know
Yeah,
if something is?
Caroline
How do
will
you
do
know if
that.
something is annuity?
Yeah, I'm thinking.
One thing. Just focus on one thing. In this,
Because it's annuity, right? So it's annual. So it's like over like a certain period. Like so it's like each month or each year.
no.
But for compound interest, you can also have stuff
Don't
for.
jump
Oh.
to the conclusion. Don't jump to the conclusion. First, see the difference between compound and annuity. The basic difference is either we are in this problem, are we making sequence of equal periodic payments?
Say again, sir. I couldn't hear you.
Are we making sequence of equal periodic payments in this problem number 41?
No, we just. Oh no, we just pay 1,000 in an account.
Kathleen, are we making sequence of equal periodic payments in 41?
No, because you're only trying to find interest for those 6 years, right?
No, no. Are we making sequence of equal periodic payments here?
No, you're just making one.
Yes. So it is not an annuity.
Oh, so annuities are payments over payments like of a specific
It
like
should, sequence of-
measure over a period.
it should be a sequence of equal periodic payments.
Okay, so like $10 a month. Okay.
Understand?
I understand now.
So in this particular problem, everybody can take the picture of this problem number 41 because I want
Yes.
a whiteboard. Did you take it?
Yes.
Okay.
Yeah, get
So I tried to solve this problem. If $1,000 is invested, we know that principal amount is 1,000 into an account that earns 9.75% compounded annually. So R is 9.75. Compounded annually means M is 1 for 6 years. T is 6. Find the interest earned during each year. During each year. So S times P 1 plus R by M first year. I am writing here T equals to 1 for the first year. So P is 1,000, 1 plus 9.75% divided by 1 raised to power 1. You will get, let's say, S1. Understand?
Yes.
Yes.
First will be S1 minus P. Understand?
Mm-hmm.
Okay. Yes.
For the second year, he is saying calculate interest after every year. For second year, it would be S2 1,001 plus 9.75% over 1. Now this is second year. So here we will write
2. Yeah.
So interest will be S2 minus S1. Is that clear?
Yes.
And we will continue this for S3. And interest will be S3 minus S2.
S2.
Yeah.
Right? There would be another way of solving as well.
Isn't it for S3 divided by 1, 2, right? In the
No. Simple
No?
as minus 1. Now there is another way to do this.
Oh, right. Yes.
For S1, it is 1,001 plus 9.75% raised to power 1. So interest is S1 minus I. Now S2 will be, here you can write S1 1 plus 9.75 and here you will write 1, not 2. Is that clear?
Yeah.
The difference
Yes.
between this and
Yes.
this is S2, this is
Yeah.
also S2, but here we are writing original principal amount, so we are writing here 2. Here we are writing the last S1, so here again it is 1.
Yeah.
Is that clear?
Yeah.
Okay,
Which one is a better equation to use? The first one or the second one?
whatever you like, no problem, both are fine.
Oh,
Whatever
okay.
suits perfectly, you can use that one, right?
Mm-hmm. Okay.
So now, uh, I think you cannot see my book now. A newborn child receives $20,000 gift toward college from her grandparents. How much will the 20,000 be worth in 17 years? Question number 61. And he is getting 20,000 from his grandparents. After 17 years, what would be the worth of 20,000 if it is compounded 7% compounded quarterly? Carolata, you are out of the room. Okay.
Sorry.
Okay, I think that is your old message. I just saw it on the WeChat. Please accept me in the room. You are already in the room. So we have only 4 students today, right?
Yes.
Yeah.
Okay. So in that case, this is compound interest. Simple. You can use the formula and you can get the answer. Is that clear?
Mm-hmm.
Yes.
Yes.
So now actually there are so many problems. Now we have this, you can, I will drop down the assignment. We have next tutorial tomorrow, right? So not tomorrow, maybe day after tomorrow, right?
No, Wednesday, 11 p.m. I think.
Today is Tuesday.
Yeah, Tuesday.
Yeah, then tomorrow. So I dropped assignment. You will go through from that assignment, and on Wednesday we will discuss your problems and one more thing related to that topic, because first I want you to solve some problems, then you will have more knowledge, more practice, more grip, then you would be able to understand better. Okay, ma?
Okay.
So today
Okay.
we'll do the assignments, and then tomorrow we'll have another lecture to discuss them. Yeah.
Yeah.
Okay. Which assignments do we need to do? Is it in the WeChat group?
I draw. Did I put assignment last time?
Is this lecture 8?
I don't know.
Oh, okay.
I let me check. Uh, did I put?
It's a bit confusing because lecture numbers are not the same as assignment numbers, which are not the same as
Actually, I
chapter
just
numbers.
messed up with this because there were so many students. So now, how many assignments do you have, by the way?
We have, I think, 1, 2, 6.
Okay, you can just continue the numbers because on the blackboard I have the record. I can check it there that how many assignments do we have. Maybe numbers are different, but number of assignments would be the same. Anyways, I will drop the assignment now in the group and also on the BB. So you will go through from it and we will discuss your problems tomorrow. Is that clear?
Yes.
Yeah.
Okay, so
Yeah.
your feedback on in the group that if do we need to improve or do we need to improve, if we need to improve in which direction, in which sense do we need to improve or thing like that.
Maybe if we have a tutorial today and not tomorrow, but on Thursday instead. No.
Actually, we had tutorial on Saturday, but
Yeah.
some students had time conflict, so they discussed
Yes.
me and mailing. So I put everything on mailing. I said just decided with the student I am available throughout the week because I am
Yeah.
in my home and I don't have anything to do other than just teaching you guys. So I just tell her you can fix any time. So now it is Wednesday, 11 p.m. Tomorrow, 11 p.m. we have tutorial.
Yes.
Yeah.
Mm-hmm.
So I will schedule the meeting. So it is already scheduled. I will just schedule it on Zoom. So